Hi, I'm Andy Sharp, and today we're going to do example 6.10 on page 258. The question is, calculate the heat released in kilojoules per gram of aluminum reacted with, and that is thermite. And the delta H is for thermite is 12.4 kilojoules per mole. And it gives us the equation: 2 aluminum solid plus thermite solid goes to aluminum oxide solid plus 2 iron liquid. So for this problem, you have to know the equation delta H of reaction equals delta H of products minus delta H of reactants. And this little asterisk here says to find the delta H unknowns in the tables on Isidore. So these other delta H for anything other than thermite is found on the Isidore things. So that for aluminum and aluminum oxide and iron are all on Isidore. So we write those in. That's what this step is here. And you remember to multiply it by the coefficients. So for iron on the product side, you have to multiply it by 2 because the coefficient number is 2. So that's 12.4 times 2, which is 24.8. And then you subtract that whole value, multiply together and add it together, and subtract that by the reactants, which is 2 coefficient of aluminum times 0, because the coefficient of aluminum in its solid state is 0 for delta H. And you add that to the delta H of thermite, which is negative 800, not thermite, but thermite, to negative 822.2. And then you subtract those, and that equals negative 822.8 kilojoules per mole. And because there's 2 moles of aluminum, which is what we're looking for, you divide 822.8 by 2, and you get negative 411.4, and that's kilojoules per mole, but we want to find it in grams like it says in the problem. And so we convert the grams by using the molar mass of aluminum, which is 26.98 grams per mole. And so negative 411.4 divided by 26.98 grams equals negative 15.25 kilojoules per gram.